Alright class, today we're going to look at graphing trig functions. So first ones we're going to look at our graphs of sines and cosines, and we're only going to deal with, if you remember, the stretching and compressing from horizontal and vertical. So if we look at the parent functions, we have y equals sine of x and y equals cosine of x. We'll graph those in a minute. We're only going to look at situations like this where there's something being multiplied to sine or cosine, and remember that's like your vertical stretch, and we're going to call that something else down there. And then you remember the b value is like your horizontal, which was always the reciprocal. So horizontal stretch, vertical stretch, compress. Okay, so we're going to see how that affects sine and cosine graphs. So for a sine curve, you should all know that at 0 radians, the y value is 0. Then at pi over 2, so we're going to go around the unit circle, we get up to 1. This is 1. Then at pi, we're back at 0. Then at 3 pi over 2, or it's 270, the y value is negative 1. And remember, these values are always between negative 1 and 1 for the parent. And then finally, to go all the way around the circle, to complete one period of a sine curve, it is 2 pi. So this is what one cycle of the parent function looks like. And I'm going to just put arrows to show that this will keep going forever in both directions. Cosine is similar, except for we start at 1. Because if you remember, at 0 radians, cosine is 1. That's the 0.10. Then we have pi over 2, pi, 3 pi over 2. So I'm just going around the circle in halves, and 2 pi. So we start at 1, then at pi over 2 when sine is 1, it's 0. Then at pi, cosine's negative. Then it's back to 0, and then we finally get back to this 1. This is harder to draw. I like doing them in pieces, so then it's just going to go like that. Okay, so that's the parent function for both of them. So we're going to see how these values change it. So the amplitude is basically your a value, and it's the distance from the middle line. I think it's also called the node, midline or node, to the top or bottom, also known as the crest and trough. Okay. The period is the time it takes for one cycle to complete. And here's where, so it's equal to the a value. So to find the period, there's a formula for it. The period is usually 2 pi. But because there's a b value, and it's always the reciprocal, to find the period when there's a b value, it's 2 pi divided by that b value. That is important. Write that down. Well, you should be writing everything down, but you know what I mean. And then the interval. So what I talk about with interval is, if we look back at the parent function up here, the interval for every time we want to put a point is pi over 2. Okay, how did we get that? Well, the period's 2 pi, and then we get pi over 2. It's by dividing the period by 4. So, all you have to do to get the interval is to, it's equal to the period divided by 4. And that gives you your spacing, kind of, or your interval, as it's called. So now it says graph one complete period. So we need two things. We know the amplitude is 4, and since there's no b value here, the period is equal to 2 pi over 1, because there's a value of 1, or 2 pi. So, which means our interval is 2 pi over 4, or pi over 2. So it's very similar to the original sine graph. So we're at 0, pi over 2, 2 pi over 2. So this is how you can do your intervals if you want. 3 pi over 2, and 4 pi over 2, which is 2 pi. So 4 pi over 2. So, do you see how it goes up by pi over 2? It's just that up above we simplified this one and this one. The only difference here is the height of the curve is now, it goes up to negative 4, or sorry, up to 4 and down to negative 4. So now I'm going to graph it. It's a sine, so we start, by the way, sines always start at the midline, which the midline here we have no shifts, it's always going to be 0. and then it's at the top, then at the midline, then it's negative, then it's back at the midline. So here is the sine 1 period of the sine curve. Again, the only change from the parent is that it expanded by 4, which makes sense. It's like a vertical stretch. Okay. We didn't talk about negative. But remember, negative reflects graphs. So instead of going up first, we're going to go down first. So I need to get a couple things. My amp is equal to 2. My period is equal to 2 pi over a half. Well, if you guys do that math, actually that's the same thing as multiplying by 2, dividing by a half. So you get 4 pi as the period. So that's where you should end. The interval, or our spacing, is 4 pi over 4, or pi. So that means that every tick mark is going to be a pi. So it's pi, 2 pi, 3 pi, and then 4 pi. And I start at 0. My height will be 2 and negative 2. It reflected, and because it reflected, it starts at 0, but it goes down first, so the values are opposite of what they would have been, just like our transformations back in semester 1. So this is what this curve looks like. It goes from 0 to 4 pi, and it is going between negative 2 and 2. Okay, let's do another one. Cosine of 6 pi. Well, this time the amp is just equal to 1. And we have a cosine curve, which means we're going to start at either the top or the bottom, not the middle line. The period is 2 pi over 6, which is pi over 3. Okay, so that means it's very compressed. This is a compression. The interval is when you divide pi over 3 by another 4, which is pi over 12. So that means my spacing is going to be going by pi over 12s. And sure enough, you should always have 4 tick marks. The last one is, if you simplify that, pi over 3, which was what our period was supposed to be at. Alright, so then we're going up to 1, down to negative 1. It's a positive cosine graph, so I'm going to start up at positive cosine, then I go to the 0, then I go to negative cosine, then I go to 0, and then I go back to up to the positive 1. And then I try to make a nice curve. Okay, so all of these are very similar. All we're doing is dealing with these tick marks are changing in numbers by finding the intervals, and our amplitude numbers are changing, and then our curves could reflect. Alright, so that was a cosine. So now we have to write the equation given the characteristics. So I'm already telling you that my A value is 7, but I'm telling you the period is pi over 6. So I have to figure out what the B value is so that I get pi over 6. So that means that pi over 6 is equal to 2 pi over B. So if you cross multiply, you get B pi equals 12 pi. So B equals 12. Alright, so now and it's a sine curve. So all you have to do is write an equation. You have to do y is equal to our amplitude, which is 7. It's a sine curve, so we do sine. And then we just found the B value, so it's going to be 12x. Alright, so now the next one we're going to look at cosine. The amplitude's 5, so we already know our A value. The period is 9. So if we figure out what that is, that's saying that 9 over 1 is equal to 2 pi over B. So you cross multiply, 9b equals 2 pi. So we get B is equal to 2 pi over 9. Okay. So we get an equation of y equals the amplitude, which is your vertical stretch, cosine, and then our B value is 2 pi over 9, which then times x. We need our x or theta or whatever you want to use for your variable. Alright, so on these ones you have to figure out the amplitude. We're kind of doing the same thing. I need the amp and I need the period. Well, the period's very simple for this one. It goes from 0 to 2 pi. So 2 pi equals 2 pi over B. So the B value is just 1. It's not shifted any way left and right. And if you notice, this is 2 here, which means this is 1. So our A value is also 1. We have to figure out what curve it is, though. It starts at the middle line. So it starts at 0. When it starts at 0, that's when sine, remember, sine starts at 0 for our unit circle. So this is a sine curve, but notice what it does first. It goes down. It doesn't go up. It has negative values first. So this equation is actually a -1 sine of 1x. And I put those 1s in there so you know that they go there. Do you need them? No. So if you're like, wait, do I need the 1s? No, you do not need the 1s. Let's do one more. This one starts at 0 here, and that's a 4 up there. And it's a cosine graph, and it ends here. So you have to figure out one cycle. I didn't show one, I showed more than one cycle here. So the period is 2 pi over 3, and that equals 2 pi over b. So clearly you could just look at this, or cross multiply if you want, but to get 2 pi over 3, b needs to be 3. So my b value is 3, my a value is 4, because it's up at 4, and it's cosine, because it starts at one of the tops and bottoms. Since it's a positive first, it's positive. So my equation is a +4 for a cosine of 3x, because my b value is 3. So that's how you write the equations off of a graph. You figure out one complete cycle, which would be from here to here. That's one period. And then go from there. And that's how you graph sine and cosine with only vertical stretches, compression, and horizontal, which would give us the period. And that's it. I will see you guys later.